So for this question, we have A, which is 3 by 5 matrix, B, which is 5 by 6, and C, which is 6 by 3. So you know that, so recall A times B is defined if number of, so if you have n times m and then k times r, then that must be m must be equal to k. So the two close by dimensions must be equal. Or in other words, the number of columns of the first matrix must be equal to the number of rows of the second matrix. Okay, so here let's just start with A. So we have C times A times B transpose. I'm writing it like that because I want to put the indices there. So C is 6 by 3. A is 3 by 5. And B is 5 by 6. So right away, you see that these two guys we can multiply because this is 3 and 3. The number of columns of C is equal to the number of rows. So CA makes sense. But when you multiply, the dimension, the new dimension is going to be 6 times 5. So number of rows of the first entry cross or by number of columns of the second one. So that's the first part. But we have BT. When you take transpose, you remember transpose changes the columns and rows. So it means that the transpose will turn the dimension B transpose is going to have 6 rows and 5 columns. And right here, you see that the number of columns of the first matrix is not equal to the number of rows of the second one. So this not defined. The second one, A transpose plus BC transpose. So A, let me put transpose out so that I can put the dimensions down there. A is 3 by 5. B is what? 5 by 6. And C is 6 by 3. Okay. So first thing to check is that, okay, B, we can multiply B to C from the left. And then when you multiply, what you will get is BC is going to be a 5 by 3 matrix. And then at the end, we are going to find the transpose. We have not done that. How about A? When you find the transpose, the number of rows and columns changes. And A transpose have 5 rows and 3 columns. So far, so good. But then the second entry I want to bring in. So A transpose is 5 by 3 plus. When I apply the transpose to BC, the number of rows and columns, which before was 5 by 3, will change. So it will be 3 by 5. Now I have two matrices. One is 5 by 3 and the other one is 3 by 5. I cannot add two matrices with different dimensions. So the products are defined, but the addition is not defined. Addition not defined. For addition to be defined, your matrices that you're going to add or subtract, they must have exactly same dimensions, same number of rows and same number of columns. Nice. Part C, A transpose C transpose. So plus, oh, sorry, no, that's D. Okay, I need to do C first. Uh, A times B, then find the transpose, plus B times C, then find the transpose and add these guys. Very nice. A is 3 by 5, B is 5 by 6, B is 5 by 6, and C is 6 by 3. Okay, so here, yes, we can do this and we can do that. So AB is going to be a 3 by 6 matrix, and then we are supposed to find the transpose of that, plus BC is going to be a 5 by 3 matrix, and then we are going to find the transpose. When you find the transpose, the number of rows and columns are going to change. So far, everything is good. But again, here, we are now trying to add two matrices which don't have the same number of rows. They don't have the same number of columns. So that means that addition again, not defined. Let's do D now. A transpose C transpose plus B. A is 3 times 5, and C is 6 times 3, and B is 5 times 5 by 6. So this is A transpose. When you find the transpose, you will switch this, and C transpose, the number of rows and columns will switch, and then you have B, which is 5 by 6. You here notice that, okay, I can multiply A transpose to C transpose because the number of columns of the first one is equal to number of rows of the second one, and as a result, the product matrix is going to have 5 rows and 6 columns, plus B, which is 5 by 6. Oh, I have two matrices which have the same number of rows and same number of columns. Yes, I can add them, and that right away gives me D is correct. Why C is not correct? Because you already did. Okay, so A times B transpose. Let me quickly write this. Oops. A C plus A, B, and then transpose. A is 3 by 5, B is 5 by 6, and this is 6 by 3. And what will happen? This will say the same, but the transpose will turn that around. So B transpose is going to have 6 rows and 5 columns. And right away, you here see that you cannot multiply them. And that will give us the answer that we already find. Part D is the right answer for this question.